Hi all, we all like to have a smartphone, LED screens, electric cars and many advancing technologies in our daily life. But do you know that none of them are possible without few elements better known as rare earth element? And these elements are the key ingredient in magnet, batteries, ceramic, polishing, etc. So the only way we can obtain these elements is through mining, which seems free, but mining has several environmental issues such as air pollution, soil and water contamination, radioactive contamination. Not only this, it also impacts our health. For example, like heart disease, bone toxicity, infertility, etc. So because of all of these reasons, RE mining was almost stopped in United States in around 2000. So as of now, China is the leading producer of rare earth element with 50% worldwide mineral reserves, and we are mostly dependent on import only, which is not good for our economy. So what option we have? Either we can recycle rare earth element from industrial waste or end of consumer life product. So research community is trying very hard to identify efficient method to recover rare earth element from industrial waste or end of consumer life product. Bio-based strategies, they have several advantages of these methods are very promising to recover rare earth element from industrial waste. Recently this protein called modulin has been identified, and this protein has a natural binding affinity for rare earth element. So the big idea is here, if we can separate this binding fragment from this big protein and we can decorate on the surface, and then later we can separate this rare earth element and then we can recycle this rare earth element again and again. So what I'm doing in my research, I designed a peptide based on this original sequence and tested this peptide in solution, and we found out that this peptide maintained binding affinity in solution, and later we will functionalize on the surface and we found out the binding affinity. But real world problem is that we need to separate rare earth element from each other. So we need a peptide with a different affinity. So what we did, we designed multiple peptides based on different affinity, and we tested these peptide in the solution, and we found out that this peptide maintain a binding affinity for different REs, which is amazing. So what we have to do next, then we have to functionalize these peptides on the surface, and we will try to find out the binding affinity. And once we find out the binding affinity for different REs, which will be amazing, and then we will functionalize these peptides on material, and we can separate rare earth element from industrial waste, which will be amazing. Thank you so much.